All right. There we go. Okay, let's get started. We probably have like 30 minutes, so just want to learn this as quickly as possible. Let's create a new conversation. Can you help me review raw SQL syntax and concepts for my technical interview? Excuse me. All right. That's good. Resize this, we'll close that sidebar, we'll minimize this, cancel, go to SQL core, we'll paste. Alright, did they talk about create? Yep. Select where, yep. Insert into, sure. Yeah, that's a lot. Okay, let's go through it. Let's see what's important. So there's, I think this is SQL. We do select star. So this will select column 1 and column 2 from table. This will select all columns from a table name. So where we can filter. Inserting into, yep. So we'll take this example. Insert. Yep. Update. Oof. We can delete. This is brutal. Delete the entire sales department. That's sus, I gotta say. You can sort, and then sorting, what's the default? What's the default sorter? Ascending. Cool. Okay. limit records using limit. We can limit results. Okay, so we're up to the second section. Can you explain all the joins every time? I tend to mix them up. Sure. What's it? Four joins? Alright, so we have just some, well, okay, so we'll do inner join. So inner join, the way that I'll explain it is we basically take all the combinations. You kind of have to think of it like this. We take all the combinations that exist. This is probably, it doesn't actually happen this way, but let's think about it this way. Whenever you join, you're going to take every single combination of column A with table A and table B. And so you're going to match every single row with every single row, and essentially end up with a new table of the length of A times the length of B. So think of it like this. Every join basically maps every row of table A with table B. This results in a table with A dot length times B dot length rows. Okay? So that's the first thing you should kind of envision. So there's join and there's inner join. I believe that join and inner join, so inner join and join are both the same thing, right? Join and inner join. Okay, so like inner join is just you're being explicit. If you don't write it implicitly, it's an inner join. So inner join is, imagine you take this this mapped table, this resulting AB. We'll just call it, we will refer to this table as table AB, okay? So for inner join, that one is going to only keep the things that match. Only keeps the rows where the on clause is evaluates to true. Okay, so when might you want to do this? You might want to do this if you want to see like maybe a shopping cart. Maybe you had a shopping cart and you want to see what items are in the shopping cart, maybe. If you had users that had accounts, you might want to do it then. If you want to see all the accounts that a user had, potentially that too. So this one keeps only the rows of this combination table AB, only keeps the rows with the rows of AB where the clause evaluates to true. Alright? That's inner join. And we have left join and right join. left join. Let's see if it's in here. We'll take this. Okay, it's very similar, very similar. A left join. We guaranteed have every row. We get every row from A. Every single row from A comes through. Guaranteed. Even if there's nothing from B, everything from A comes through. And we get B if it exists. If the on clause evaluates to true. But we'll get at least one of each A. We'll get at least one of each A. And that A will have a matching B. Basically for every matching B that A has, we'll have another A. But if there's 0 matching Bs, we'll still at least get one A. Right join. It's the exact opposite. We get every row from B, and we get A if the on clause evaluates it true. So see if we can do a quick replace here. Okay, so yeah, inner join is you keep only the things that are common from A, B. Left join is you get every A, at least one of every A. But if you have one or more B's, you'll get more A's. The right join is the complete opposite. And then there's a full join. We get every row from A and every row from B. And more if for each on clause that evaluates to true. So if you want to think about it like this, maybe this helps a little with this AB, because one thing that I didn't mention is this idea of like table A also has like its empty row, and table B has like its empty row. If you want to think about it like that. That they get like paired with, and so A's empty row gets paired with B's empty row, and then we start going through a row from A, the empty row, another row from A, the empty row, another row from A, the empty row, and then B. Then we go through B, and so A is basically paired with empties and with values to empty, and then B is empty and all values to empty and paired. So if you want to think about it like that, so technically it's kind of like more like this. And so you have all these pairings. For an inner join, we only keep the ones that are the same. And so we go through each of these, this giant a dot length plus 1 times b dot length plus 1, go through this giant table and find all the ones where they match. And only where they match we keep them. For the left one, we basically find all the ones where they match, but if we don't find one where they match, we still at least keep one and pair it with null. Pair it with the empty row. At least for the left table. For the right one, we do the same thing. We make sure that we have at least one of each row from the right one, and if there's no pair, then we take the empty table, the empty row. The full is similar. We have to have at least one row and one row from each of the tables. I think that's a full inner join. Full outer join, JK. So this would be full outer join. Is we keep at least one of each. But if we find one, we don't have to keep the null one. So if we can't find one, we use null. If we can find one, we don't use null, we use the one that we found. But there's going to be at least one for each row, each row in each table. So you kind of have to think about this union, is it union? This combinatorial table that's a result of the join. And then you have basically these 4 joins. One where you only keep the matches, one where you get at least one from each of the left, one where you get one from the right, and one where you get at least one from both. Inner is the most common, is the one you're going to use the most. It's the one that you should know the best. Same thing with just regular join, they're both the same. But yeah, I hope that answers your question. Okay, so that's full outer join. You can highlight these, maybe comment them. Cool. Okay, cool. No problem. So subqueries. Can you show an example of a subquery? And I think this just has a select from a select. Let's actually see, did it already have it? There's group by, there's having. Oh, they didn't really. Okay, so. Alright, we get the pick. We're getting a nice little option here. And I think this one's fine. Actually, like this one more, I think. And let me just think about it. Did we need to use a subquery here? Is what I'm wondering. So we're getting the ID of the departments that are in sales, right? And so we're getting all these IDs. I'm actually surprised that you would use the equals here and not use like in. So the inner query retrieves the department ID of sales. Oh, okay. So this is just returning one ID, basically, the one in which it's sales. The outer query retrieves the first name and last name of those who work in the same department. So one returned by the subquery. So this is interesting, for sure. But you could also kind of do it with a join. You don't have to, but you could. I think it might read easier, just a little bit easier. But I mean, seeing as how, I think what's probably important here is what data do you actually want to get? And how easy do you want it to be to reference that data? And so when you separate them like this, you have the option of referencing first name, last name directly to the employees. I mean, if you just called this like name and you called the department name and you did an inner join, then you might have issues picking the right name, and so you'd have to say like employees.name, and that's a little annoying. So you got to think about like the context of joining and when it might be good or bad. The other thing is, when you think about joining, like I was saying, you kind of have to think about this idea of this giant union set potentially, theoretically being made. And so you're like comparing every single row against every single row. And you gotta think about how expensive that could be. Now, if you use indexes and whatnot, you're gonna have a much better time and much more optimal. But in theory, you are essentially creating this union set. So this has the potential. It only goes to this table once. It only goes to this table once. Whereas an inner join essentially goes through both tables based on the size of each. And so you're doing that like n squared algorithm. So something really important to keep in mind. Yes, there are like optimizations that do happen, but you gotta imagine that it's not optimal. And you gotta think about what's most optimal. Most optimal is one n followed by another n. That's much more optimal than a potential n squared. Which one do I prefer? I prefer the right one because it doesn't do the limit thing. Now the limit thing is interesting, adding the limit, because if you know that there's only one department with sales and you find that one, maybe the limit makes this query just a little bit faster. It's still n, theoretically, but it has the option to at least opt out early. And so considering things like adding a limit is really important. Okay, and I remember seeing a group by and having earlier. So let's pull that out of here. Here's the example. So we got a count star. Let's just take the having. The having's perfectly fine. And I don't think you can only use something that you've included in this aggregate here. You might also be able to say like as total. Let me see. Can this be rewritten? As let's see what they say. No, you can't. You have to repeat count twice. You can't use the alias total in this case directly in the having SQL. SQL does not allow the alias to be referenced in the having because having clause is evaluated before the select clause. Interesting. Hey, the average brain, how's it going? I'm only on for like 10 more minutes right now, but because I have an interview at 1:30. I'm just doing a quick review session of SQL. But I'll be back on maybe around 3:30 after I kind of collect my learnings from the interview. And then at that point I'll probably do like an hour-long stream, just so you know. Just gonna be a little bit shorter this session due to interviews. But I'm just preparing for a technical interview. Okay, do we have group buy? How was your weekend, by the way? I don't know if you watched the Super Bowl or anything like that. Alias, we do alias. Distinct removes duplicates. Group by having clauses. The original query, not in this query count is computed in having clause. Based on the results. Attempt to rewrite not valid. Cannot be referenced in having clause. This way the query still works, you still have the same count expression in having. Alternatively, if your database supports common table expressions or subqueries, you can use them to reference any alias in the having clause. Interesting. This is something to consider. Because like to me, counting is potentially slow. And so you gotta think counting is like n. And so this is like n squared. And because it might not actually be n squared, but you still should think of like worst case. I don't know how counting actually works. It might be faster, but like you only count once and then you do the join, or you don't join, you subquery it. This one you count twice, which you technically have to figure out the size twice, and that might be expensive, more expensive than figuring it out once. So it's good to know that doing a subquery in this case is actually better, most likely. Okay, so we have having, group by and having, we have group by, we have having. We're doing it all at once. Okay, we have data types, normalization, and database design. Alright, can you tell me? Okay, so I'm pretty sure normalization is this idea of like having foreign keys and storing references to things rather than storing them directly in the table. Yeah, so reduces redundancy. So decomposing table into smaller, will structure tables using relationships between them. The goal is to minimize the chance of data anomalies, such as update, insert, delete anomalies, and make the database easier to maintain and scale. Normalization is achieved through a series of normal forms, which typically involves moving first normal form. Okay, this is, hopefully no one asked us. But yeah, this is what I was saying. You shouldn't have subjects like this. You should have IDs. That would be better. Because if I change the name in math here, and maybe I was using the subject as the key, I would have to change the name here. It's really difficult to change an ID once you have the ID in the system. All right, this is a little advanced, but this is just like a principle of relational databases. I'm pretty familiar with this, pretty familiar with that. Seems I'm pretty familiar with that. There's create statements. I don't think we'll be asked about create statements. It's pretty rare. Excuse me. There's indexes and performance optimization, which I also think I'm pretty good at. None of these, I mean, these two are data, these two are syntax. This one's syntax. This is syntax. These are specialized functions. Oh, you're at school. Nice. Indexes and performance optimization. Let's just ask ChatGPT to tell us more. I'm doing all right. I'm excited for my interview. A little nervous, but mostly excited. So there's single column index, composite index. I also, I had a good weekend. I really enjoyed the Super Bowl. Got to watch it with my family. I had brunch on Saturday. It was a nice meal. Tried somewhere new in the area that I recently moved to, so it's good. So it helps with wheres, joins, order by, group by, create index on. Yeah. When not to use indexes, columns with low selectivity. Column has many repeated values. Indexing may not help as the database will still need to scan many rows. Interesting. That makes sense. Index maintenance. Indexes, as data is inserted, updated. Indexes must also be updated over time. Indexes can become fragmented, which may reduce their performance. How to manage index performance? Rebuilding indexes. Some databases allow you to rebuild and reorganize indexes. Defragment them, dropping unused indexes. Indexes that are not being used by queries can be dropped, saved, storage, and improve write performance. Interesting. That's good to know. That's cool. I did not know you could do that. You might not always be able to do that. In case indexes get fragmented. Explain is cool. Need to know the details of a query's execution. Use explain. Explain will tell you what exactly it's doing at the like the actual code level, like step by step, and you see the some of the automatic optimizations that are happening, and some of the maybe some reasoning why it might be slower. So explain could be really helpful. And this is a composite key here. And it depends on like what order you usually which ID you usually select by first. So maybe you have, maybe you usually select by the employee ID, but you have the option to also narrow down to the department ID. Okay, cool. Let's look through here. We have having distinct alias. This one's a little intense, the data types. You usually only do it for create statements, which I don't think we're gonna do. But yeah, I know this wasn't like super thorough SQL review, but I do have to get ready for my interview in 10 minutes. So I will be back around 3:30, I would imagine, Eastern time. And then I'll do like an hour and a half stream. But yeah, thanks for popping in. Thank you. Alright, I'll see you guys later. Thanks for joining in. Bye for now.